All right. How's everybody doing? Woo! All right. Cool. Well, welcome to the session. This is Build and Scale Your AI Apps with Kubernetes and Arc. So we're going to be taking a look at how you can use container and modern application development technologies to build applications out at the edge connected to Azure for control and management and consistency. I wanted to start out by taking a look at the application lifecycle challenges that you have in these distributed environments. So whether you're looking at retail stores or you're honestly looking at a place like this, a conference facility, or you're monitoring oil infrastructure or other places that happen to be remote or need to be physically disjoint, I don't think any of us really want to go to Microsoft Build inside of one of our data centers. As cool as that might be, I think Build has to be in a conference place, and that means we need to be able to build compute and compute solutions in this conference place to build even things like the displays by the door that show what the sessions are that are happening and things like that. When you look at these distributed environments, there's a lot of challenges, from a pretty fragmented ecosystem of tools and services to a lot of sort of manual tools and techniques that have been developed in the past because there wasn't a way to connect these places to the cloud. I think you can only need to look back a little ways to see a fairly major incident that caused a lot of airlines, railroads, and other things around the world to shut down, and people actually literally had to run around putting USB sticks in to recover these systems in certain circumstances, right? So that fragmented ecosystem and manual management of these services makes it really, really hard to do something, and also the operational toil of physically having to run around with a USB stick or something out like that. What that means then for these edge environments is that you're going to have fewer app releases, and you might think, well, maybe I don't have as many features that I need to deploy, maybe that's not such a big deal, but you have to realize that an application release isn't just a feature that might be rolling out, it could be a security patch, and in fact, in many cases, it is a security patch or a bug. I actually had the pleasure of once going through the airport, going to put my ticket to a ticket console, and I saw the blue screen of death. And anybody ever has, obviously a number of people here have probably seen the Windows blue screen, right? So all of those kinds of operational fixes, those are rollouts too. And if we can't roll them out quickly enough, and we can't roll them out with high reliability, then we're going to sort of have to trade off reliability and security against the application's operation. And I think what we're going to see here is that with modern application development technology, with cloud-native technologies, we can actually do a much better job in these challenging distributed environments. And I want to, as a sort of proof point of this, I wanted to go through a case study that we had with CSX. I don't know how many people know of CSX, but they're a railroad company. They run shipping and that sort of thing on the railroad. And they needed to be able to do rail inspections. So this includes inspections of the trains and inspections of the railways that they're going on. And the previous to building this solution with Azure, they had to actually obviously stop the trains to take pictures, to do inspections and things like that. What they've been doing now actually is doing real-time detection of defects on these trains with remote sensing through data collection that captures the trains moving at 40 miles an hour, right? So you can see the picture of the drone there that is doing imaging of this train as it passes by without stopping. It doesn't disrupt operations. And then they do real-time processing of that data. Obviously, there's a lot of data that's being processed by these in the video that's coming back from this system. And so they need to be able to process it locally and stream it through to Azure Local, so that they don't have to push all of that video that they're capturing from a remote location, maybe wherever the train track happens to be. They don't have to push that back into the cloud itself. But because it's connected to Azure with Azure Local, they get workload performance and security, as well as more easy management, cloud-based management that you're used to, even as those applications are running out at the edge. So this means that they're doing more inspections more quickly with fewer disruptions. And I think it's really a great illustration of what you can do if you combine local deployments of software with connectivity back up to the cloud and modern techniques for managing those applications. And obviously, moving freight around the country is a pretty mission-critical application as well. And so you can see that Azure Local is a great fit, really, for any kind of application that you might be using. All right, so here are the sort of solutions. If we took a look at those problems that we had before, here's how we can use Kubernetes, which is the open source container management solution on Azure and really across the industry in general and on-premise as well, to solve all of the problems that we outlined before. With Kubernetes, we can use unified tooling that manages containers in general, right? So at this point, the kinds of tooling that are available to you to build a containerized application are universally available no matter where you're developing that application. And more importantly, because of the abstraction that the container provides, it doesn't matter if it's a .NET binary, if it's a Java binary, if it's a modern Rust binary. It doesn't matter if it's a Windows container or a Linux container. All of the tools and techniques for managing those applications are identical once you've taken your application and packaged it up as a container and pushed it to someplace like the Azure Container Registry. And because of that centralization, because of that sort of, I used to call it a runnable thingy. You can think of it sort of like a cassette tape, or if you're old like me and remember cassette tapes, or anything else that has that shared interface. All of the tooling that you build knows how to accept something of that form factor. And it doesn't care what's on the inside. It doesn't care how you built the container image. It knows how to take it and run it. And then obviously all of the management has happened through a consistent API. The Kubernetes API provides a consistent way of describing the application, as well as a lot of tools that provide utility for operations, like automatically restarting the application if it fails, doing scale out or scale in, depending on how much usage the particular application is seeing. And then, of course, you can layer on top of it things like Microsoft Defender for Cloud, which actually, or Microsoft Defender for Containers, which can actually deploy in all of these environments and can secure your containerized workload. And so all of this comes together to really make it dramatically simpler. Sorry, I'm going to have to grab a little bit of water. To make it dramatically simpler to deploy and manage your application than what you might have been using previously for these sort of distributed environments. All right. And of course, because Azure Local runs the exact same binaries as the Azure Kubernetes service, you get the same experience whether you're building the application for the edge or you're building the application for the cloud. And that consistency extends to things like the portal and the CLI tooling, where you can actually see all of your applications that you're running in the cloud or see all your applications that you're running out on the edge as well. All right, so here is sort of the picture of all of those pieces that you can use to deliver your application using containers and containerization, because it's not really just about the container and the container image for managing your application. You need all kinds of different services. You can see the Azure Kubernetes service at the center, but there's databases that you can run, from Postgres to SQL Server, and you can run SQL Server on Azure and at the edge, using, again, the same interfaces, the same portal, the same CLI, the same infrastructure as code tooling, whether it's Terraform or Bicep. All of these tools are unified to describe your applications. And actually, in many cases, it's actually really useful. Even if you're building an application for the edge, you can deploy that application for development and testing into the cloud. You can create a test environment for every developer that they can use that has simulations or pre-recorded data or whatever it happens to be. Because oftentimes these distributed environments are either difficult or expensive to simulate for development workloads. And obviously you don't want to deploy development workloads out to the real site while you're doing development and testing. So being able to use tools to do development and testing in the cloud, while then being able to use exactly the same tools and the same platforms and the same data services and other services to deploy them back out to your distributed environment, can be a huge win in terms of agility for development teams. And you can see all of the other things that we have here. Obviously, if you're here at Build, you know that AI is a big focus for us. And so there's all kinds of AI tooling, including the Kubernetes AI Toolkit Operator, or Kaido, that there's actually many talks about throughout the conference. It can deploy to Azure the cloud and Azure local as well. Our Kubernetes marketplace, full of third-party ISV images, can be deployed into both environments. And of course, all of the open source community developed tools, again, can run in both of these places, providing that unified experience for not just your own applications, but actually applications that other people are developing for monitoring, service mesh, or many other technologies. All right, and so this, this comprehensive lifecycle management from build with all of these open source technologies, I thought it was going to animate, through to deploy with CI/CD from things like GitHub Actions, to securing and monitoring with Managed Prometheus and Grafana, to Microsoft Defender, as I mentioned before, all the way through to being able to use infrastructure as code tools like Terraform and Bicep to manage all of those applications, means that you have a truly seamless experience for developing all of these applications that span from cloud to edge. You don't have to have a cloud team and an edge team. They truly can be one team, both for development and operations, to seamlessly deploy those applications. And to see a little bit more about how that works in practice, I want to invite up to the stage Kiana, who's going to give you a demo of how easy it can be to build these apps with unified tools. So here's Kiana.
Thanks, Brendan. So before I start the demo today, I'm first going to take a look at an architecture diagram. Here in this architecture diagram is what I'll actually be demoing, and it's the deployment pattern with app development tools for Kubernetes. And this is, before we dive into things, I first want to start with what are cluster extensions. Some of you may have installed them, some of you may have used them, but what cluster extensions are they ARM-based experiences to install and manage these life cycles for different Azure capabilities. You can deploy these extensions to your clusters to support different scenarios and to improve cluster management. So now with that context, let's take a closer look at this architecture diagram. On the left-hand side of the screen here, on this side, you can see a developer working in Visual Studio Code. And for that, we're going to be leveraging GitHub Copilot today. And this developer is going to be writing a Kubernetes manifest to help deploy their cluster, specifically an AKS cluster, into the cloud. So a developer is working now inside Visual Studio Code, but whenever I talk about these extensions, what do I mean? So if you take a close look here on the right-hand side of the screen, we have Azure Key Vault Secret Store extension, as well as the ACSA extension. But here's where it gets interesting. The manifest that you see on the left here isn't just about how the app runs. It also includes declarative definitions for these cluster extension dependencies right down to the version requirements. So what app development tools for Kubernetes does is it's really emphasizing this compatibility and governance for these versions, for these extensions. It's version controlled, it's repeatable, and more importantly, it helps ensure a secure, compliant, and consistent deployment every single time. So let's actually go ahead and take a look at GitHub Copilot within VS Code. I don't know why. There we go. So here I have GitHub Copilot already open, and I'm going to actually go ahead and create a prompt here. And it is to generate a Kubernetes deployment manifest that includes Azure Container Storage enabled by Azure Arc and have the Secret Store extension with Azure Key Vault integration. And you can see here as GitHub Copilot is working, it's using a few references that it's finding online, and you can actually see that it has now deployed or created this manifest. Now as part of that, I can go ahead and right-click here and insert that into a new file. And here you can see the persistent volume claim for ACSA is now created. Again, that's the Azure Container Storage enabled by Azure Arc, PVC. You can see the sample deployment here, as well as if I scroll down, you can see the secret provider class for the Secret Store extension. Now, if you aren't familiar with these things, no worries. GitHub Copilot takes care of all of that. If I scroll down here a bit, it will show you some notes about these different things that it's created. For the purpose of this demo, I've gone ahead and already created a sample app deployment. And here, if I close GitHub Copilot to give you a better look, you can see that this manifest looks very, very similar to what was generated by GitHub Copilot. Here you can see that we have, again, the deployment. You see that we have the volumes, more specifically for the ACSA client. We have the container registry image for for ACSA, as well as the volume mount. And if I scroll down a bit here, you can see the PVC as well as this storage provider class. This again was all generated through GitHub Copilot, and again, this was this sample application was generated from GitHub Copilot, and then I then inserted my variables into that. So let's take a look at ACSA and Secret Store Extension deployed in the portal. Here I have an Arc-enabled Kubernetes cluster already deployed. And here, if I scroll down a bit, you can see the different extensions that were already installed. If I go to the extension side here on the left, you can see that these different versions are already available for Secret Store Extension as well as ACSA. And this suffix here on the ACSA, as well as the Secret Store Extension, is showing that these are all part of the app for development tools for Kubernetes. These foundational services are validated to ensure that they can work with one another and continuously updated together rather than individually, and are then bundled to minimize the downtime and disruption of workloads, allowing the developer to focus on writing the code and not infrastructure, since that's already taken care of. To just summarize what we did here today, we showed how developers can work fast and stay in the flow with their Kubernetes environments, using GitHub Copilot and VS Code for that. And with app development tools for Kubernetes and Azure Arc, the extension requirements like ACSA and the Secret Store Extension are defined declaratively, making deployments secure, repeatable, and environment aware. Back over to you, Adam. I'm going to go ahead and pass it off to you to talk a little bit more about app development tools for Kubernetes, and talk also about how we are deploying apps not just in the cloud, but in the edge as well.
Still. There goes. Thanks, Kiana. So here we're going to talk a little bit about the pieces and the extensions that Kiana just walked us through. The goal here was to extend the services that we use in Azure that you can use to develop against the hyperscale environment in Azure, make it a consistent experience for as you develop your apps and bring them to the edge. So we extended the Azure services via Azure Arc so that we have consistent dependency management across the cloud and the edge. So these are delivered, as Kiana mentioned, as a set of version-compliant Kubernetes cluster extensions that enable you to build, pin, and then verify and consistently roll out across your Kubernetes infrastructure. So this includes Azure Container Storage enabled by Arc, which gives you local, resilient, and fault-tolerant capable storage at the edge, and as well as unified secret management via Azure Key Vault Secret Storage. So and then finally the consistent monitoring and telemetry experience via the Azure Monitor extension. So these are all delivered via Azure Arc through enabling resilient operations in the event of connected or disconnected events, as your edge can kind of go in and out of connectivity. As Brendan called out earlier, in those railway scenarios, you may lose connectivity for a period of time and come back, and you want that consistency while you're going in and out of connections to happen as well. And so these extensions enable that consistent development from cloud to edge and through resilient operations. So now we've seen how we go about building. We're going to move to the next step of how we go about deploying and enabling scaling across your environments, where you can have a large distributed fleet, whether it's through railways or retail stores or manufacturing facilities, anywhere that kind of requires your data to stay local. You may be processing large amounts of data at the edge or have latency sensitive applications. And we're going to look at how we build and extend AI applications to run across this distributed infrastructure, leveraging the extensions we just talked about. So this morning we heard about how AI Foundry is the AI app and agent factory, where developers can go design and customize and manage AI applications at scale across all of your infrastructure. And we believe that AI should be able to run anywhere. If you build it for the cloud, you should be able to extend it to the edge in a consistent way, a consistent, easy way to leverage the AI close to where the data is to enable those low latency scenarios, and where the data's can't flow back to the cloud, but you want more real-time operations. So today we're going to talk about how we've enabled a subset of the AI Foundry models to be brought out to the edge via the AKS running in Azure Local. So this is going to talk through that. And so customers can use, as Brendan mentioned, the Kubernetes AI toolchain operator to deploy the models across both the cloud real estate for AKS as well to AKS clusters running on Azure Local. And so Kato is a open source Kubernetes operator that automatically allocates GPUs and resources, then makes sure that the full life cycle kind of the model can deploy into the cluster, run, do the inferencing, fine tuning, and the deployment of the models in a consistent fashion. So it runs natively on AKS and both in the cloud and at the edge. And so now we're going to hand over to Kiana, who's going to show us how it all comes together.
Thanks, Adam. So again, I'm going to start with another architecture diagram before I dive into the demo. So this architecture diagram is showing how we're going to deploy and operationalize retrieval augmented generation, also known as RAG applications, across both cloud and edge environments using AKS, AKS on Azure Local, and the Kaito extension. So these solutions address a common challenge that a lot of manufacturing and retail spaces find. This can be anywhere from low latency to local data control to regulatory compliance that restricts this cloud-only solution. So to meet these demands, the architecture enables consistent AI model deployment across both cloud and edge infrastructure. So taking a look at the architecture diagram here, on the left-hand side of the screen, you're going to see a developer again working in Visual Studio Code. Now, today we're going to be using the Kaito extension, and we're also going to be using the Kubernetes extension to access the Kaito workspace. And what this Kaito workspace does is you can really fine-tune the open source models, test model behavior, and then deploy them to your Kubernetes cluster. So taking a look closer here at the AKS cluster, once models are ready, they're then deployed here, where Kaito manages the packaging, the container orchestration, and API exposure for inference at scale. Taking a closer look here at the Azure Local cluster, this is of course with GPU. The same thing is extended to the Azure Local cluster. And on the edge, an NFS share holds these private data sets. This can be anywhere from PDFs like manuals, logs, and that's what we're going to actually show here today. And this is where the RAG pipeline is to ground these model responses in real-time context-rich data. And this design supports low latency use cases while keeping data sensitive that is on site. So the application retrieves these relevant documents from local NFS, passes them through the RAG engine, and then generates these grounded responses using the deployed LLM. And that's without requiring internet access or cloud dependency. So let's first take a look at our AKS cluster. Here I'm already set my kubectl context to the AKS cluster, and I'm actually going to show that we have a GPU node. For that, I'm going to use kubectl get nodes. And here you can see my GPU cluster already. Now I'm going to also show you my Kaito pod. So if I use kubectl get pods, here you can see my workspace. Now, what I'm actually going to do here is I'm going to tail these logs. So for that, I'm going to use kubectl logs, this workspace, of course, -f. And these logs are going to continuously run as I access VS Code. And I'm going to keep this running in the background, and I'm going to go ahead and minimize this window. But just a reminder that it's still running. Now, I'm going to jump right into VS Code here. I do want to highlight that we have both of our cluster extensions here. We have both the AKS in the cloud as well as AKS on Azure Local. And here you can see you can create the Kaito workspace. You can access all of these open source models, whether that's Falcon, whether that's Phi 2, Phi 3. For this demo, we're actually going to be using Phi 3.5. But regardless, you can access this Create Kaito workspace by right-clicking here on the Jumpstart AKS cluster, hovering over Deploy an LLM with Kaito, and then clicking Create Kaito Workspace. Similarly, you can also click on Manage Kaito Workspaces, or Kaito Models, which will then take us to this page. And here we already have one deployed, so I'm going to go ahead and click Test. And I'm going to go ahead and submit a prompt. I'm going to ask this prompt here, what are the benefits of migrating to Azure? And through submitting this prompt, if I'm quick enough, I can go back to my command prompt here and see that this response was received. You can see all of the different parameters that I had specified within VS Code, and you can see all of the different responses here, as well as, like I said, the different parameters. So with that, now keeping that in mind, that was AKS in the cloud. Let's hear from Husqvarna on how this can be done at the edge. Let's switch back here. There's to be sound with this.
years. The biggest transformation that we are looking at right now is actually around data. How do you build powerful AI solutions on top of our data?
AI is the key for the future here to really utilize the data in new ways and new technologies.
Utilizing Azure OpenAI was really easy because we were already on board with Azure, and then having generative AI included was truly a key enabler for us to being able to build the Factory Companion. The Factory Companion is a web application, so when you speak with the Factory Companion, you are provided with answers based on our own Husqvarna data. Azure Arc really provides us with the benefit of having on-prem infrastructure being managed in the same way as we are managing cloud services. That enables us to reduce the amount of development times needed to get our solutions out into production. The game-changing aspect of Azure Arc is for us to get cloud services and be able to choose where we should put our workloads.
We can reduce the time spent on solving problems, for instance, 25 to 75%. We are moving the boundaries of how we have built up the IT environment for manufacturing in the future.
What if we could see one day that we can see the end-to-end flows through our entire value chain of the company? That is what we're aiming for.
All right, so it's cool to see how Husqvarna is taking AI to the edge. Now let's see what it looks like in the real world. Here I have my AKS on Azure Local Cluster up. Already pre-configured, I've already set the proxy, and I've also already chosen to use kubectl get nodes. Here you can see that I have different nodes running, but I'm actually going to go ahead and describe one of these nodes and specifically look for GPU. I do want to show that we have GPU allocatable and available here. So if I scroll a bit up here, you can see that I do indeed have a GPU available and allocatable. So now that we have that, what can we do to actually visualize this? And what we have now today is the application to query this Kito endpoint. So here we have an already application, and we have this data source already preloaded. If I take a look at this data source specifically, you can see that we have 5 different files that were already uploaded. These files contained anything from refrigeration user manuals to HVAC user manuals, and that's what I'm going to actually be showcasing in this chatbot today. I also do want to highlight here at the bottom that we have the chunk size as well as the chunk overlap. And here that can actually be specified when you are uploading your data source. So what does that actually look like? If you want to upload a data source, you just click Add a Data Source, and then to change the scheduling updates as well as the chunk size or chunk overlap, you can modify that here as you review and finish. So taking a look at the chatbot here, I have already asked the chatbot, tell me more about my HVAC system. And again, this is querying and looking for all of the data sets that I had already uploaded. This is the PDFs of the refrigeration manuals, the HVAC manuals. Now, based on this, it gives me a response from these PDFs, and now I can ask it, how do I turn on my HVAC? And as this generates, it might take a few seconds. As this generates, it will generally also give a response. So based on this, you can also see that it is querying or using or leveraging these references that were already created. And here you can actually look at the reference that was used is specifically this HVAC system user manual for Contoso Hypermarket. So after seeing how this can be applied to real-world scenarios like Husqvarna at the edge, and seeing how that we can interact with this data locally, and you can also see that we had also interacted with the AKS cluster through VS Code and the Kubernetes extension, I'm going to pass it back off to Adam to talk a little bit more on securing and monitoring these deployments.
Thanks, Kiana. So the next leg here, we've talked about building the applications, we've talked about deploying them at scale across your distributed infrastructure. Now we're going to talk about how do we complete the cycle, make sure we're doing it securely, that we're monitoring how things are going, and that we're reacting when there's issues out in the field or at your distributed edge location. So what we have here is a lot based on Azure Monitor, built on top of Azure Monitor, we can offer centralized observability of your containerized app real estate, both from cloud and edge. So this allows us to pull all the metrics and telemetry from the distributed infrastructure logs together into one spot. funnel it into Azure Monitor, which is managed service for Prometheus, which gives us time series data and starts to build the views there, leveraging and combining with Container Insights to form a complete monitoring for your Kubernetes environments. So you can leverage AI-driven investigations for faster root cause analysis when you see issues via app alerts or portal pop-ups or infrastructure issues you may be having to more quickly identify and remediate issues across your AKS footprint, leveraging Copilot in Azure. So today we're excited to announce a public preview of Azure Monitor dashboards with Grafana. So this service will enable us to take all this data that we've pulled together into a unified singular approach built on top of Grafana and give a singular view of all your data coming together, all based in the Azure portal. So dashboards with Grafana enable you to create and edit Grafana dashboards directly in the Azure portal, leverage Azure RBAC for sharing, and develop automation with ARM that will enable ARM and Bicep to continue to deploy and update these over time. And now I'll hand back over to Kiana, who's going to show us how it comes together.
Thanks, Adam. Again, let's start by painting the picture of Grafana and Prometheus. This architecture today illustrates how Azure Monitor dashboards integrated with Grafana provide this end-to-end Kubernetes observability across both AKS and AKS on Azure Local. Again, this is at the edge. So this solution supports a wide range of dashboard options. This includes anything from Azure template dashboards to imported Grafana community dashboards, which is what we'll get to see today, as well as user custom dashboards. And these dashboards are powered by Azure Monitor data sources and then are rendered using the Azure Managed Grafana service, which then offers a centralized interface for telemetry, visualization, and analytics. So taking a closer look here at the Azure Monitor Managed Prometheus side of the house, at its core of its observability stack is the Azure Monitor Managed Prometheus. And this acts as the primary data ingestion layer. And this data ingestion layer is compatible, and it stores and it scrapes metrics in a compatible format that only the Prometheus ecosystem can provide. So supporting both real-time and historical data insights. And complementing Prometheus, of course, we have Azure Monitor. Here you can get anything from metrics to log analytics to app insights to Azure Resource Graph. And this is all offering this unified view of cluster performance, of application health, and infrastructure insights. And these observability capabilities are not just limited, of course, to AKS. They're also with Azure Arc. So the same monitoring infrastructure extends to these Arc-enabled Kubernetes clusters that are at the edge. And by centralizing these metrics and logs from AKS and edge-deployed Arc-enabled Kubernetes clusters in Azure Monitor and visualizing them through the Grafana dashboards, operation teams gain these powerful insights, whether that's through troubleshooting, monitoring, or taking a closer look at optimizing their Kubernetes-based workspace. And they're all running in the cloud or on-prem. So let's actually take a look at what I mean by Grafana dashboards. Here again, I have two clusters. One is AKS in the cloud, and one is AKS on Azure Local. These are the same clusters that you had seen previously in my other demo. So taking a closer look here at this AKS in the cloud cluster, if I scroll down a bit to the monitoring section, you can actually see that I have already configured this Managed Prometheus. Now this is important because if you are planning on using the dashboards that I'm going to be showing you today, this has to be configured. Similarly, for the AKS on Azure Local Cluster, I have an extension already installed. Specifically, the extension that I'm looking at is this Azure Monitor Metrics extension. Again, this is important because in order for you to be able to visualize these dashboards and use these dashboards, this extension must be made available. So taking a closer look here at my Azure Monitor workspace, if you navigate to your Azure Monitor and then navigate down here to Dashboards with Grafana Preview, you can actually see all of the different dashboards that you get out of the box. So as I had talked about in the architecture diagram, all of these different dashboards are all built in. You don't have to do any work yourself. They're already created for you. If I scroll a bit down here, you can see that you can look into anywhere from insights for applications, for containers, for Cosmos DB, for Key Vaults. There's just an endless amount of different visualizations that you can get. But for the purpose of this demo today, I'm actually going to be using this dashboard here, which is the Kubernetes Compute Resources Namespace Workload. And as this loads, I want to point out that both of these clusters are already pointing to my Azure Monitor workspace. And you can see that data source here. Again, both my AKS cluster and my AKS on Azure local cluster are both pointing to this data source. And I really, really want to highlight here that these views that you're seeing are going to be the same for both your AKS cluster as well as your AKS on Azure local cluster. So let's take a look. Here you can see the CPU usage, the CPU quota. There's endless amounts of visualizations that you can get here by looking directly at this dashboard from out of the box. I can also change my cluster here again to my AKS cluster that's in the cloud. And again, you get the same look and feel as you did with that AKS enabled on Arc. So I'm also going to actually show here the Cube system, which shows you a little bit more of the telemetry, and you can see a little bit more insight as to what kind of CPU usage you're getting, and similarly, you can look at the CPU quota and the memory usage. Proactively, we can see these capabilities that are the world of Grafana that hasn't been embedded, but let's also take a look at how we can actually import community dashboards. So if I click on New, and if I click on Import, and if I click on this Browse Grafana Dashboards Gallery button here at the top of the screen, it'll actually take you to the Grafana website. And here are the Grafana dashboards that you can import from the community. Today, I'm actually going to be using this Node Exporter Full. So clicking on this will take you to the actual dashboard itself, where you can visualize and kind of see for yourself what you're getting out of the box by downloading this. But if I actually scroll down here a bit, focus in on this copy ID to clipboard, I'm going to go ahead and click on that and navigate back to my Azure Monitor workspace. And it's very simple. All I do is Control-V, and you get the ID that I had just copied. I'll load it in, give it a title, select my subscription, of course, select my resource group, and select my Prometheus or my Azure Monitor workspace. Clicking import here, which might take a few seconds, you'll find that this dashboard is easily importable. So you can see now that this data source for your Azure Monitor workspace has already been completed. You can see anything from CPU usage to memory and disk performance. And if you scroll down here a bit, you can see some other metrics as well. Again, that's from the community itself. You didn't have to do any work other than import an ID and upload it yourself. So like I said, proactively, we can see these capabilities that are the world of Grafana or the world of Prometheus. And we talked about the observability, but let's also take a look at how we can troubleshoot an AKS cluster. I do want to call out that this is in preview. So if there are any issues that pop up today, that's the beauty of AI, and that's the beauty of live demos, right? So here I have an AKS cluster already spun up, and I was able to get to this sidebar here by clicking on the Copilot button here at the top. Clicking on that, I already have generated a response here, because it does take a few seconds to go through it and actually process my data, but from that, I was able to proceed with this cluster, and then I actually chose the last 24 hours for it to do an analysis on. And the question that I had asked, if I scroll a bit back up, are there any issues with my AKS cluster? And I know, of course, for this demo, there are a few issues with this cluster, and you can actually see that it's found that there's some subnet issues. Now, clicking on this, it'll take you to a few different documentations and a few different analysis that it has done. But if I scroll down here a bit, I actually also ran a deep analysis on this cluster subnet. And it goes a little bit more in depth as to how I can remediate and how I can resolve this issue. And you can actually see here that it provides the suggested solution, and it also provides relevant documentation in case I didn't happen to come up with a resolution myself, or a Copilot wasn't able to offer me the response that I was looking for. So let's actually go ahead and take a look again at how I can also use Copilot here. So have I had any issues with scheduling pods? I, of course, know that I have had issues scheduling pods, but I'm going to go ahead and ask Copilot that. And as this generates, what it should produce here as it generates is a run command. And when I click on this run command, and so it takes a few seconds, I can go ahead and click yes, and it'll go ahead and automatically bring up that run command. It already has pre-populated the command that it has given me, but for this demo, I actually just want to see my pods. And for that, I can leverage the Copilot prompts that are already pre-populated. So I'm going to actually go ahead and click on Show Me All Pods. Copilot generates, and then it comes up with kubectl get pods for all of my different namespaces. Sure, I like it. Let's try that. So I'll go ahead and replace it. I'll go ahead and click Run. And as this runs, it should list all of my pods. And let's scroll up a bit here. You can see all of those are running, and I do see one terminating. But if I scroll up some more, you can actually see that there are some pods that are stuck in the pending state. Specifically, I have 3 unschedulable pods as well as 3 bad image deployments. So now that I know that I have a bad image deployment, I'm going to go ahead and ask Copilot how I can fix that. If I go ahead and actually type that in, I can see an error. So I'm saying here, I see an error for pods in my bad image deployment. Help me figure out why these errors exist and how I can fix it. Now, I can actually go ahead and click down here on the bottom right-hand side, this Copilot button that you see. And here with Copilot, it's working on my response, and it'll actually generate the command that I'm supposed to run in order to take a closer look at this specific pod. So I'm going to go ahead and click Replace. It populates that for me. And as this generates, of course, with live demos, not everything works out, but as this generates, it will tell me a little bit more about this specific pod. So what if I want to see anything more? Like what if I want to visualize what my performance looks like for this cluster? For that, I'm actually going to move back to the right-hand side of the screen for this Copilot experience, and I'm going to go ahead and ask it, what is the performance of my cluster like? Now, as this generates, this one does take a few seconds, but what you'll see here is some different visualizations for anywhere from unneeded nodes to scaled cooldown times or cluster health. Here you can actually see the average CPU, and as this generates, it's going to move my mouse down. But the average CPU usage you can visualize here, as well as the average network in bytes. But what if that wasn't enough? What if I want to see a little bit more? And for that, I can actually just ask Copilot what other performance metrics are available on my AKS cluster. And again, as this generates, what you'll see here is CPU usage, regular cluster health, in-flight requests, and it'll come up with a long list of different things that you can actually check out yourself if you want any other performance metrics. Let's give it a few seconds here to generate. It does take some time. There we go. So here you can see it gives a very, very long list of different things that you can actually take a look at or what is available for your AKS cluster. So as a recap of today, we took you through the end-to-end flow of this building and deploying and securing and monitoring and managing these applications at the edge and in the cloud. If you want to try out Kaido or the Azure Managed Prometheus demos that I showcased today, then you can actually go ahead and check them out through the Jumpstart drop. And then I'm going to pass it, actually. So, no. It's like this button's not working.
Uh-oh. We can't go back anymore.
We can't go back, yeah. We're stuck here.
We need AI to try.
Oh,
there it goes.
There we go, there we go.
You have to wait for the AI request to go in.
So here's what I was talking about. Sorry for the small hold up there. But if you actually wanted to go and try out these demos today, specifically the Kaido extension, as well as the Azure Monitor Workspace demo that I had showcased today, go and download that. That's available for you to try out in your own environment through Jumpstart drops. You can access that through the aka.ms links there. And I also want to take the time to recap the different public previews that we also talked about. I won't go through the whole list of everything, but feel free to go and check those out. There's plenty of other sessions that are part of Build this upcoming week. So if you do want to check those out, there are some 3 sessions that are also part of this organization, are also part of this space, and you can check those out yourself. But more importantly, if you want to go to Arc Jumpstart, there, again, you can download things from out of the box. It's really just a way to help you get started quickly and try these things out for yourself. So thank you, everyone, for attending today. I think there's one more slide. And as always, feel free to take the survey if you enjoyed our session. But have a great rest of your time at Build, and thanks, everyone.